As buildings grow in height and complexity, so do the demands of the structural system. At the same time, engineers are increasingly asked to do more, with less. Less material, less time, less carbon, all while delivering more strength, more efficiency, and more design flexibility. So how do we meet these competing demands without compromise? Welcome to the ArcelorMittal International channel, where we talk all things structural steel. Let's talk ASTM A913, a high-strength, low-alloy structural steel with a yield strength up to 80 KSI. In this video, we're going to discuss why you use it and where you use it. One of the most defining advantages of A913 is its increased yield strength. Where conventional structural steel, like A992, offers a yield strength of 50 KSI, A913 is available in grades 50, 65, 70, and 80, delivering up to 60% more strength. That means you can achieve the same structural capacity with smaller members, reducing overall tonnage, saving money, and reducing embodied carbon. An increased yield strength is most beneficial in strength-controlled applications, the most common of which is gravity columns. We can see an example of gravity columns illustrated here. We have a 6,000 kip load and an 11.5 foot unbraced length. On the left-hand side, using A992 50 KSI steel, our design is a 14 by 500. As we move to the right and increase yield strength, the size of the member goes down. Going all the way to A913 grade 80, that results in a design of a W14 by 342, saving a total of 32% on the weight of that member. In addition to the cost savings on the section itself, there is also a cost savings associated with welding. A smaller section requires a smaller weld, which results in less weld volume and fewer man hours in the shop and field. When you consider that a single weld on a heavy section could take dozens of man hours to complete, the savings become significant. When you extrapolate that across an entire project, the savings could be in the tens or even hundreds of thousands of dollars. Trusses are another common application of A913, and the same concept applies: higher yield strength, smaller sections, and smaller welds. A913 can be used for transfer elements, long-span trusses for stadiums, or even outrigger systems. An additional benefit of A913 that shouldn't be overlooked is weldability, or the relative ease in which it can be welded. A913's strength is derived from the quenching and self-tempering process, rather than conventional alloying elements. More on the QST process in a different video. Less alloying elements result in lower carbon and generally lower carbon equivalent values for A913. Lower carbon and carbon equivalent values means A913 is less susceptible to cold cracking after welding. This, in turn, means that less precautions need to be taken prior to welding, such as preheating. All grades of A913 are pre-qualified under AWS D1.1, and this chart shows their corresponding preheat temperatures. A913 grade 50 and 65 require no preheat for all thickness levels. Grade 70 requires no preheat up to 2.5 inches of thickness, and grade 80 follows the same preheat as A992. Preheating steel can be intensive. It can add a significant amount of time, cost, and embodied carbon to a project. And last but not least are the sustainability advantages of A913. In the hierarchy of sustainable design, using less will always be more impactful, and A913 is a great way to build clever and build efficiently. And remember, you reduce embodied carbon by 100% from the material that you don't use. That's all for now. Make sure to like and subscribe to stay up to date on the latest and greatest in structural steel.